Okay, hello everyone. So today we're going to be talking about angles of triangles. Today we're going to learn how to prove the triangle angle sum theorem, and we're also going to talk about the exterior angle theorem and practice applying these theorems to solve certain problems. So let's start by talking about some definitions. Well, what are interior angles? Well, say we have a triangle ABC. Well, the interior angles are these angles right here. They lie inside the triangle. So angles that lie inside the triangle. Exterior angle is a little different. So say we extend one of these sides. So you can extend any side indefinitely, which means they can go on forever, and you create this little angle right here. The exterior angle is an angle formed by extending a side of the triangle. Well, what are remote interior angles? Remote also means far away. So far away interior angles. If we're looking at this exterior angle, the closest angle that is interior of the triangle is angle C. So angle C is closer to angle BCD than angle A and angle B. And so remote interior angles are the non-adjacent angles in a triangle. And then I'm going to put in parentheses, furthest away from an exterior angle. So they're the non-adjacent angles in a triangle that are furthest away from the exterior angle. A corollary is a result of a theorem that can be proved. We also are going to tackle some new theorems today. I'm going to explain them as we use them so that you can see how to apply them. For example 5.1.1, it says find the measure of each numbered angle. There's three numbers. There's angle 1 right here, angle 2, and then angle 3. So in order to solve for this, we need to learn what the triangle angle sum theorem is. And that just means in any triangle, the sum of the three angles, so I'm using my example up here, those three angles, A, B, and C, those have to add up to equal 180 degrees. So angle A plus angle B plus angle C equals 180 degrees. And again, this is the triangle angle sum theorem. Let's try to apply that now. I'm looking at triangle KLM. So I know angle LKM. So I'm that's me talking about this angle right here, plus angle KML, which that is angle 2 that we're trying to solve for, plus angle MLK. That has to equal 180 degrees. Well, let's plug in what we know. What is the measure of angle LKM? So LKM, that's the 71 degrees. So 71 plus, what is the measure of KML? KML is just the measure of angle 2. And what is MLK? MLK is that 57 degrees. Well, now we can solve. So we would have to combine like terms. So 71 plus 57, that is an 8. And then 7 plus 5 is 12. So 128 plus the measure of angle 2 equals 180. And then if you solve for the measure of angle 2, the measure of angle 2 would have to equal 180 minus 128. So that is about 52 degrees. So that's one of our answers. I'm going to box it so that I know that that's my answer. That's one of them. What do we know about angle 1 and 57? What do they lie on? Well, they're on a straight line. So again, we can use that idea of a linear pair. If you have a linear pair, these two angles that lie on a straight line, well, they have to add up to something, and that something is 180 degrees. So I know the measure of angle 1 plus 57 degrees equals 180 degrees. And then simply just solve for angle 1, subtract 57 from both sides, and you get 123. So 123 degrees is the measure of angle 1. And then finally, we just need this measure of angle 3. To find that, we would have to use the triangle angle sum theorem again. We know what angle 1 is. This is 123, so I know the measure of angle 3 plus 123 plus 28 has to equal 180 degrees. Combine like terms. So this is 151. So the measure of angle 3 plus 151 equals 180. Subtract 151 from both sides, and you get the measure of angle 3 equals 29 degrees. Okay, so we're seeing that we can use the triangle angle sum theorem to figure out the remaining angles of a triangle. We could also use the idea of supplementary in certain cases. For example, these two, they were on a straight line, so we knew that they added up to 180. Let's try example 2. Well, I can't necessarily start over here, and the reason why is because there's two unknowns. So if I try to set this up using the triangle angle sum theorem, it won't work out because now I have two unknowns. But over here, I do notice that there's one unknown angle. So let's set that up. I know 43 plus 74 plus the measure of angle 1 has to equal 180 degrees. Well, 43 plus 74 is these add up to equal 7, and then 7, 8, 9, 10, 11. 117 plus the measure of angle 1 equals 180. Subtract 117 from both sides, and we get measure of angle 1 equals, that would be 63 degrees. Well, what is the angle relationship between 1 and 2? I'll give you a second to try to take a guess. Well, angle 1 and angle 2 are known as vertical angles. And what do we know about vertical angles? Well, vertical angles are always congruent to each other. They're the same. So, because I know that the measure of angle 1 is 63, I can say that the measure of angle 2 is also 63 degrees. And then finally, we can actually solve this. We can solve this by setting this triangle sum up. So 63 degrees plus 79 degrees plus the measure of angle 3 has to equal 180. Combine like terms, 63 plus 79, that is a 2, carry the 1. 142 degrees plus the measure of angle 3 equals 180. Subtract 142 from both sides and we get measure of angle 3 equals 138. Or no, not 138, just 38. Sorry. So the measure of angle 3 equals 38 degrees. The last example on this first page is a proof. So we're actually going to prove the exterior angle sum theorem. Or it's just called the exterior angle theorem. My apologies. So here's what we have to start off with. We start with this triangle ABC, right? And you know. So let's start our proof with let triangle ABC exist. And then we're going to say we extend line AC, or side AC. Extend side AC to a point D. Well, what do we know about angle 1 and angle 2? What do those have to add up to equal? By definition of a linear pair, we know that the measure of angle 1 plus the measure of angle 2 has got to equal 180 degrees. But what do we know about these angles as well? On the interior of the triangle, right? They also have to equal 180 degrees. So by the triangle angle sum theorem, we know that measure of angle A plus the measure of angle B plus the measure of angle 2 has also got to equal 180. What do we know about 180 and 180? Are those different or are those the same? If they're the same, then what does that mean about these two expressions? They also have to be the same. And so using substitution, we can say that measure of angle 1 plus the measure of angle 2 is equal to the measure of angle A plus the measure of angle B plus the measure of angle 2. Now, do you see anything that's the same on both sides? Right? This measure of angle 2. And so once we cancel out, we can subtract that from both sides. We end up getting our answer. The measure of angle 1 equals the measure of angle A plus the measure of angle B. And hence it's shown. That's proof. This is the great result. So it's saying that this exterior angle is the same as the sum of these two remote interior angles. Let's flip this over now. This problem is dealing with architecture, and it says, find the measure of angle DAB in the front face of the building. The measure of angle DAB. So we want this exterior angle. But what do I know about this exterior angle? What two angles on the interior of the triangle is it equal to? Well, the measure of angle DAB is equal to the measure of angle B plus the measure of angle C, because those are the two remote interior angles. A is right next to, so we take B and C and sum those two up. Now we're just going to use substitution to plug everything in. So we know that the measure of angle DAB is 12x plus 7. The measure of angle B is 6x minus 4. And the measure of angle C is 65 degrees. So now we have an equation. We can solve for x. And then once we get x, we plug back into the original expression. So let's combine some things. I'm going to bring down what I don't use. I'm not using anything on the left side. Bring down my equal sign. I know 65 minus 4 is a 61. So 6x plus 61. Let's subtract 6x from both sides. If I take away 6x from this side, I have to take it away from this 12x. And I get 6x plus 7 equals 61. We can also subtract 7 from both sides. If I do that, I get 6x equals 61 minus 7, that's 60, 59, 58, 57, 56, 54. Now we need, well, what is the opposite operation of this multiplication? So these two are multiplying. The inverse operation is division. So we take both sides and divide by 6. So 54 divided by 6 will give us a 9. So we know that x equals 9. But we're not quite finished because we want the measure of angle DAB. So what I'm going to do is I'm going to take this 9, which is our x value, and plug it into our measure of angle DAB. So the measure of angle DAB is equal to 12 times 9 and then plus 7 afterwards. So 12 times 9, that's an 8, carry the 1. 108 plus 7 equals 115 degrees. So the measure of angle DAB is 115 degrees. Now we're going to skip activity 5.1.5 and 5.1.7. However, we will do 5.1.6. If you would like to try those activities, feel free to do so, and then bring me your answers, and I will be glad to check them. But okay, so 5.1.6, it says find each measure. That means all of these missing angles, this expression, this expression, this expression, and this expression. We need to find the missing angles. Take a moment and try to start this, okay? So I know that there's a lot of different triangles. There's a lot of different routes that you could take. Me, for example, though, I will start with this triangle right here so I can find my x. And I notice that if this is 90 degrees, then this also has to be 90 degrees because they lie on a straight line. So they form a linear pair. They add up to 180. One of them's 90. The other one has to be 90. So I know, using the triangle angle sum theorem, that 90 plus x plus 8, which is this angle up here, plus 2x minus 2 is equal to 180 as well. Oops, maybe I should turn the light on. Looks a little better. Right, and combine like terms. So x plus a 2x makes a 3x. 90 plus 8 is 98. 98 minus 2 is 96. And that's still equal to 180. Subtract 96 from both sides. 180 minus 96 gives us, let's see, 180 minus 96 gives us an 84. So now I have 3x equals 84. Divide both sides by 3, and you get 84 divided by 3, which is 28. So I know my x value already. X is 28. Well, now I can plug in those two expressions and find my answer. So the angle right here will be 28 plus 8, which is 36 degrees. And 180 minus 90 minus that angle we just found, which was 36, is equal to 54. So I didn't even have to plug in x right here. You could double check, but I know that this is 54 degrees now. To find the value of y, we want to use this triangle up here. We know that this is 5/4 y minus 45, and this is y. That is also 90. So I can say 5/4 y minus 45 plus y plus 90 is equal to 180. Well, let's combine these two. 5/4 plus y. Well, I don't know. It looks a little tricky to combine at first, but let's multiply this number by something. So there's a 1 in front of this, and I want it to have a denominator of 4. So in order to do that, I have to multiply 4 in the numerator and the denominator. So I get 5/4 y plus 4 over 4, which is still 1, okay? So 1y. And then what is 45 or 90 minus 45? Well, that's just 45 still. 5/4 plus 4/4 is 9/4, so we get 9/4 y. And let's subtract 45 from both sides. If I subtract 45 from both sides, I get 135. Multiply both sides by 4. So 135 times 4 is 540, and then divide by 9. And you get 60. So I know y equals 60. So when I plug that in right here, this is 60 degrees. Well, I know that this is 90, so these two angles have to add up to equal 90, so the remaining angle is 30 degrees. And so this is how you're using the triangle angle sum theorem and the exterior angle theorem to solve these kind of problems.